Alright, so we have a quick practical, quick hands-on onto BigQuery, and I come with some use cases. Like remember that last video we have seen data sets like similar to Rapido, like a CityBike. So let me go through this. So if you can see there that I will get into the BigQuery, and into the BigQuery we have your studio, and once we come into the studio part, we can go onto our ad platform, right? So when you go to this ad, you have a multiple options like local file, you have a Google Cloud Storage, you have a connection, and parallelly today we are going to discuss about how to work with additional data sets, right? So public data set is all about. So in this public data sets you have a different use case. So I will go to with CityBike like last time we have already I have seen there. So let me have it, city dataset. So here we have CityBike. Okay, and this is what we have a brief about this. We have discussed about how it works. All right, the data set's been there. So let's have a quick let me get inside my data. Okay, write me on city. I will write it there, city, and I will finalize the data set. So here we have a CityBike data set. So let's we go, and in this data sets you can see the data is coming. You have a schema. In the schema you have a trip duration. You remember that when you traveling they will ask you first OTP, station, your trip started, and your trip stop. So that is all about the trip duration, start time, stop time, station ID, station name. All the information is coming onto your part. So this all the information is completely gathered by this your station name, longitude, you have a GPS, right, being activated. So this complete information, whenever you're taking the ride, this information they hold. So in this part, a data set is having 7.47 GB data, and I'm coming with some use case. So 58.93 CR data sets we have. So I was talking about when you are looking for any cab. So mainly what you do, you take a cab of Uber and you try to find out the cab, right? And let's say for an example you're in outskirts. So in that case what will happen, and the services, mainly the outskirts, are not easily available. So it keep finding the resource, finding the cab, not resource, sorry. So in that case what will happen, you finally fed up and you switch to Ola, right? You switch to Ola and you find out that your service is available and you get the cab and been there. So in this case you notice that Uber lose one customer, and also you know that it's a mouth publicity. A person reached to destination, and after that it's giving the feedback, and kind of that service is not easily available in Uber. You know that these all the services are more into mouth publicity. So this is where Uber lose one customer because of lack of service. Okay, now talk about the second use case. You are in the city, okay, and in that case you are looking for a cab, okay, and you find that the cab is available but the charges are slightly higher. In that case what you do, it's very simple, right? What you do, you go to open the Ola, and in that case you find out the service, the price is reasonable, and in comparison to Uber it is lesser. So of course we will book the Ola and get it. So in such cases where we find that ultimately the Uber is getting the loss, okay, because of fair price, you can say the fair price is lesser. All right, so what we should do in such cases? Okay, today I'm having a data set. We are having a multiple, almost 59 CR data sets, rights available, and I'm trying to figure out something analysis, right? What analysis I will give it to you today. So I will check the traffic, right? I will give you a simple analysis today. Okay, this analysis is all about you know that I will check the traffic. So I will try to give us some solution to some extent this problem that this Uber can resolve this issue for it. And also you can give your prediction analysis that you're open to do that. So in that case I will write a one SQL query and try to figure out what is the traffic, right? What is the traffic? What are the most of the cabs are getting booked, right? So I will write the one use case that is you have. Okay, so I'm using all right, this is simple query I'm writing. Okay, to know the traffic, and in this I will try to paste it. Okay, so here we have a data, and something interesting you can see here. Okay, something interesting you have here this side, your validator, right? You see that the validator is saying that to process this data, it need only 3.3 GB data. You remember that? What is the data size we have? The data size is what, 7.47 GB data. But in this case, when I'm looking for traffic to understand what is the data set it is needed. So Google validator test say that, hey, to run this job, you need only 3.3 GB data. That's really interesting. Means I do not need entire data set, that is a 7.4 GB data. So this is something that concept is coming from, that is called capacitor, or in terms of if you understanding of columnar database. So based on the that concept, it is filtering the data and giving you the exact data for this particular query, how much data it required, and the charges will come only on 3.3 GB data. So that is what Google helps you in terms of cost optimization also. Now let me run this job. So to process 3.3 GB data, let's see how much time it takes. I will execute this job and let's see. Okay, so the job started and it's completed. Okay, here's the result. You can see, let me make it large. You can see the result. Okay, but I will come back onto this result later. You see the job information, right? So you can see here the duration, it takes 2 seconds, means 3.3 GB data, it takes hardly 2 seconds to process it. It's quite you know that why the robust technology is equally important. Either you're a data engineering or you're a data scientist, right? A platform does matter, and here the Google is giving you that platform, a very robust, and you know that it's a very fast to process 3 point some GB data. It's take 2 seconds, 3 point, and you can see the billing, right? The bill is also coming on 3.3 GB data. That's interesting. Means out of 7.4 GB data, I have to pay only for 3.3 GB data, and the slots, the milliseconds, right? Many information you can see here. It is coming 10259. The job priority is interactive. Something is called the output has been stored on temporary table because it's being stored into the cache. If you have option to store onto permanent table also. And let's see, go to the result. This is the result you have, right? And the result, it show something. You have a start station, so it's saying that from this station to this station, all right, people taken the cab from this, and this is the destination. How many trips? It's 18, 16, 7. So this is what the traffic I have. Now earlier, how this traffic can help me. So I'm coming on to this part, the problem that we are facing, that the no service, and because of the fair price we have a loss for that, and how this analysis can help me into that. So I'm going to show you into the, you know, that a database, not in the table, but yes, we have a data. Okay, so this is what Looker Studio. So it's kind of data visualization tool. If you're familiar with the data visualization tool, you have a Power BI, you have a Tableau. So similar, we have a Looker, that is an ecosystem of BigQuery. So here you can see the output in the graphical format. We have all the graph formats, so we'll see how it looks like. So you can see the chart, and the analysis is now coming. Okay, and now this graph give you too much clarity. You can see this the blue, and this one 60%, right? The 60% plus, it's not 60%, 60% plus cabs has been booked from this area. Means it must be dense, and the traffic is too high. It must be the heart of the city, and where the traffic is more. So this is the area where we are getting more traffic, and you see that some slightly changes, right? So it might be the traffic, you can see it's very lesser. You can say that yes, the traffic is lesser because of maybe that it's outskirt, or or the people are not being more active to get the cab. So this gives you the clarity about this. Now how you can match with this, that's the question, right? So I'm coming to this part. Let's say if you are into outskirts, so what I will suggest from this analysis, if your service is not available, right? The problem is that, let's say the service is not available, right? So what you can do it in this case, for example, right, under Uber, first thing what I will suggest from this analysis, let's say in Bangalore city, under Uber we have 1,000 cabs registered under Uber. So it's very important for you, that to distribute, right, to distribute this cab into this area, because it is equally important. The cabs are available, but the cabs are not available to the place where that more traffic. So it is equally important that cabs should be available where the requirement lies. So it's a 60% this area is being covered, so you can put 60% or plus into that area, and according to that the bandwidth or the traffic, what the bandwidth you have the cab, you can distribute and you make the cabs available. So users should not face this challenge, that the part we are talking about. Users should not face the challenge to get the cab, right? Service should be available. I'm not saying that it's the solution. To some extent or to a great extent, it can give you the solution for that. Now, the second part, we were getting that price. Now, if you see in the second case, the service is not available. The service is available, but because of charges, right? The charges are a little higher. So the rider preferred to take a cab from your competitor. So in that case, what we can do it, where you have how you will decide the price factor, right? How you can reduce the margin, how you can increase the margin. So that is equally important. So in this case, what we can do it, the place, right? The place where we have more traffic, we can reduce charges, right? The fare charges. Of course, if you have a more traffic, it's very, I guess, if you are getting the quantity, all right, we can reduce the price and we can match the margin, right? The place where you have a very less traffic, you can increase the charges, the fare charges. People won't mind to pay you if you are, because when they are not getting the service and they are looking forward to available cab, so you see that if they're getting the service, their priority is to get the service, not the price, because they have a very less options to get this the cab service, right? So here in this outskirts, where you have a very less traffic, you can increase the price. Where you have a more traffic, you can reduce the price. So you can balance the service and that pricing both. So it's kind of analysis which I have done, and that you can do your analysis and you can give the more better that prediction or kind of suggestions. So such kind of use cases. The more important thing is that I did this analysis on the real-time data sets, like I told you, it's real-time, but it's old data sets, but it is equally good that if you're working with such data sets, it gives you a feeling to that work, what industry working right now, that kind of platform or that kind of environment you're working. I guess that's all for today, and hope you learn, and mainly people from the SQL, they should do more practice with some real-time data sets. That will give you more understanding about and get a more that how BigQuery can be more useful for you than your the current platform you're doing. Thank you. Hey, don't forget to download our app for access to free courses and interactive quizzes. Stay connected with us on social media for updates and free content. See you next time. Happy learning.